So youth need to be engaged in developing solutions that uh, will be able to level up with the problems or challenges emanating in the world of agriculture. So technology is the key to unlock African agriculture potential. That's the So why should you join us? Yes, we are creating a future we want in agriculture, and we connect you to the world of information, which comes in terms of opportunity, scholarship, internship, and volunteership. So also we share skill development, and we are doing this through project collaboration, community interaction, then university workshops and symposiums all around. So we also give you access to coaching and mentorship from our industry leaders and professionals. So at Precision Field Academy, we are building a community of young tech inclined and digitally savvy professionals. Okay. So I quickly want to talk about the program again, Precision Agriculture Incubation Program. It's a digital agriculture training, a youth-centric digital agriculture capacity building program from the staple of Precision Field Academy, the classic African Digital Agriculture Training School, causing rapid transformation in the global agriculture sector through comprehensive and expository training of youth on the concept of precision agriculture technologies and its application to solve today's pressing challenges emanating in the agricultural landscape to strengthen and stabilize economic prosperity. So, recognizing the transformative potential for precision agriculture, we understand that there is a urgent need to equip young emerging farmers, agricultural professionals, and aspiring agripreneurs who falls into the demography of youths with the need for requisite knowledge and skills to harness this technology effectively for global opportunity and exploit. The Precision Agriculture Incubation Program (PAIP) addresses these needs by providing comprehensive training in key areas such as drone technology, GIS, data science, robotics, IoT, machine learning, personal and corporate branding, and entrepreneurship. So through this program, previous cohorts participants were empowered to embrace innovation, optimize their farm management practice, and contribute to overall advancement of agriculture sector by creating local content digital solution and the technology they've learned in the course of they are now applying directly in their farm practices and also helping other farmers who are short of this knowledge. So basically we have seven objectives that led to the creation of the Precision Agriculture Incubation Program. So number one is to close the knowledge gap and the skill gap. To close the knowledge and the skill gap of participants about precision agriculture technologies and practice. Number two is to raise next gen agriculture remote pilot. Number three, to groom young precision agriculture leaders and stakeholders for global exploits. Number four is to build the capacity of youth in the aspect of technology application in agriculture. Five, we're looking at promoting the adoption of innovative and sustainable farming technologies that improve agricultural productivity and resource management. Six is to foster entrepreneurship and encourage participants to develop technology driven solutions for agricultural challenges. And seventh, which is the last point on the objective, is to create a network of digitally empowered young agricultural professionals who can drive positive change in the agriculture industry. So the Precision Agriculture Incubation Program is a social impact program at PFA, and it's focused majorly on this four key areas: promoting capacity building through empowering youth with knowledge and skills on precision agriculture. Also, it's cuts across gender inclusivity, ensuring we are bridging the gender gap, giving more rooms to females to be able to learn digital agriculture technologies, be able to also leverage this and work with it in the agriculture sector. Also, it's promoting policy advocacy when youths are enlightened and they are well educated about technologies like this. When they have the opportunity to be in the government or have the power at their beck and call, they will be able to help shape better policies and make informed decisions that can, you know, transform the agriculture sector as a whole, leveraging on digital technologies. Likewise, it's also looking into research and innovation, so focusing on establish dedicated hub where we're going to have an everyday working of the people who have ideas to develop solutions in the agriculture sector. It could be from IoT perspective, machine learning, robotics, or even drone technology. Could be able to work in get guidance, training, and advice services that could guide them through the process of developing their agri-tech solution. So the training mode is in two formats. We have the on-site and the virtual. So the virtual is what we are presently doing or experiencing. The virtual master classes we have from our global faculties. And after the virtual master classes are done, we will be moving forward to the physical or the on-site practical, which will be done in the universities. So our key skill focus technologies we are looking at in the course of this cohort is drone technology, GIS, and remote sensing. We've had some classes on GIS and remote sensing, and also we are presently in the week we will be discussing more of drone based topic on agriculture spraying, general knowledge on drones, and also for mapping. And so we've discussed about artificial intelligence as well. So we also have data science, robotics, IoT, and Internet of Things. All of this is what we will be working with in the course of this training. So without wasting much of our time, so let me just bring up our speaker. So this is the topic we're going to be discussing today, and I quickly want to read through his profile, then bring him on board. Alright, so our speaker for today is David Okwateibo. He's a Nigerian, a tech-savvy Nigerian, and a drone professional. So David Okwateibo is a leading force in the Nigerian drone industry, serving as the mission director at Droneros Limited, a solution-driven company dedicated to transforming how drone pilot train, operate, and succeed. So with a mission to reduce pilot downtimes and raise professional standards, David ensure that drone operators are not only skilled but also compliant, equipped, and flight ready. So at Droneros, he has built a system that does more than fix drones. It restores confidence from cutting repairs turnaround time by over 60% to guiding hundreds of drone pilots through licensing and legal framework. David has positioned Droneros as a one-stop command center for drone professionals. He's created drone equipment solutions and hands-on training programs are tailored to the reality of the African drone space. David's focus includes designing practicals, real-world drone training programs, creating a reliable, rapid response drone repair system, supporting pilot licensing, registration, and regulatory compliance, and also providing trusted drone gears and technical accessories, growing a strong network of informed, empowered drone pilots. Driven by a vision to see drone technology fully maximized across industries, David is passionate about building resilient operators who can adapt, innovate, and lead. So his leadership has turned Droneros into more than a company. It's mission control for pilot success, where every flight begins with confidence and clarity. So for David, every grounded drone is a missed opportunity, and he is on a mission to fix that. All right. Thank you so much, our speaker, for joining. So, bringing him on board. All right. Okay. I'm not sure if I can hear you. I think you are muted. Your mic is. You can.
Good evening,
Okay.
Professor. Can
Yes, I can hear you now. Thank you.
Thanks
Okay,
for
you
having me,
have the
sir.
floor now. So we can. All right.
All right. Good day, everyone. Trust we are all good. So today I'll be taking us a session on introduction to drone technology. We'll be talking about the general scope, right, and also the technical considerations. Like Mr. Joseph already said, when it comes to agriculture, right, there are quite a number of things that can be done or that are being incorporated to ensure that precision takes place. This involves the inclusion of artificial intelligence, machine learning, and of course, drone technology. So today I'll be introducing us to the world of drones. All right. So to begin, let's consider the significance of drones in agriculture, right? So in the year to 2050, right, the global projection of the population is projected to reach 9.7 billion, right? By 2050, we're expected to have a population of 9.7 billion, right? And this has placed significant pressure on agriculture because we need to have more food production. And now this is a statistic that was provided by the United Nations, right? So they did some analysis and they projected that by 2050, the population of the world will be 97 billion. Now, of course, one thing that we know is when it comes to increasing population is that the demand for food will also increase, right? So that's a given. Now, because of this increase in population, right, the Food and Agriculture Organization, which is the FAO, which I'm sure we are aware of, noted that it's going to need this increase in population will require a 70% increase in food production. So by estimation, we are looking at a 34% increase in our population. But that 34% increase in population is not going to demand a 34% increase in food production, right? It's going to demand more. It's going to demand about double of that, right? And because this demand has to be met, some things have to be put in place, right? So on my screen now, you're going to see a quote from FAO. It says, in the first half of this century, global demand for food, feed, and fiber is expected to grow by 70%. Now, new and traditional demand for agricultural produce will thus put growing pressure on already scarce agricultural resources, right? So for us to be able to meet this demand, the way we do agriculture has to change. And that's what brings about what we call precision agriculture, right? Now, precision agriculture is a crucial strategy that optimizes resources by leveraging technology to increase productivity. So rather than doing things manually, right, by incorporating technology, we're able to make our work easy, right, faster, and also increase our production rates. Now, drones are integral part of this integration, right? And they offer real-time data collection and analysis capabilities. They enable farmers to make data-driven decisions to improve crop management practices, right? So when it comes to these solutions, we have quite a number of them. We have the incorporation of autonomous trackers. We have, like I said before, artificial intelligence, wireless telematics, yield monitoring. So one of the technology that is also incorporated to ensure that we move the space and develop precision agriculture is the use of drones. Now, before we explore further, it's essential to understand what drones are and what their evolution is in the agricultural space, right? So you might be hearing drones. Why exactly are these drones getting wave? So let's start from the very beginning. So the very first one is that drone was first developed and used by the military, right, in a variety of applications before they were being adapted for civilian purposes, right? So in the early 2000s was when it started gaining traction for the commercial use, and that also included the use in the agricultural space, and that was around 2015. So from 2015, the commercial use of UAVs became very predominant, very prevalent, and the agricultural world was one of those industries, right, that got incorporated into the system. Now, this brings us to the next one, which is the categories of drones, right? So there's a very high chance that you've seen a drone before, and if you've seen one, then it's most likely a multi-rotor drone, which is what I'm pointing to on my screen, right? But beyond that, we actually have quite a number of categories of drones. Now, drones come in different shapes and sizes and can be classified into four. So the very first one is the fixed wing drones. So these fixed wing drones are drones that are similar to your airplanes, the planes that you see in the airport. That's why they're called fixed wing drones, right? Because their wings are fixed. Now the next one we have is what we call the rotorcrafts. Now rotorcrafts are similar to your helicopters, right? So they're similar to helicopters. And then another one that we have is what we call the multi-rotors. This simply means a drone that has multiple rotors or multiple blades. Most likely you've seen them in events before, right? And then you see that it has maybe four blades, right? So these categories, the major difference about these categories is that they bring different things to bear. So for instance, for your fixed wing drones can fly for a longer period of time, right? Meanwhile, they cannot hover in place, they cannot stay in one position. But your rotorcraft and your multi-rotors can stay in one position. They can hover, they can stay on the spot, they can take off and land on a position. But for your fixed wing aircraft, you need a runway or you need a takeoff and landing space primarily. Now, this brings us to another category of UAV, which we call the hybrid UAV, which actually fuses the benefits of the two of them together, right? So we have the multi-rotor, which can hover in place, we can take off and land vertically. And then you have the fixed wing feature, which can enable the aircraft to fly longer, to fly farther, to carry heavier payloads. Are we following? Let me know if are we with me? Can you hear me? All right, good, good. Now, when it comes to UAVs, we have different manufacturers, especially in the agricultural space, right? So there are several options available for selecting a drone for agricultural purpose. And there are a lot of considerations you need to put in place. One of them is the farm size, right? The second one is the terrain. The next one is what are the monitoring requirements you have? So is your farm size pretty large? Are you just doing crop analysis or do you want to spray, right? So Precision Oak, for example, is a company that offers a variety of fixed wing and multi-rotor UAVs, specifically for the agricultural space. We also have the companies like Parrot, right, which also offers drones for agricultural space, primarily for like crop monitoring, field mapping, yield monitoring. And then we have DJI drones, which specialize majorly in providing agricultural drones for spraying, right? So you can use them to spray fertilizers, also use them to spray your crops, right? To plant your crops for seedlings. And one other thing is you also have drones that are equipped for yield monitoring, right? So depending on your use case and the kind of operations you have, your scope, how big your farmland is will determine the kind of aircrafts you need to go for. Now, this brings us to general considerations, right? So, one of the critical aspects of using drones in agriculture is navigating the regulatory framework. Now, understanding the rules and regulations governing drone use is crucial for compliance and safety. So, now we're talking drones, and then you're like, okay, why are we talking about regulations? Because that's the very first framework that you need to put in mind whenever it comes to incorporating drones. Now, drones are seen as aircraft. Drones are aircraft, not that they're seen as aircraft. So drones are aircraft. And because they're aircraft and they fly overhead, right, there's a high chance for these systems to fail. And if they fail, a number of incidences that we don't want to happen that can happen, right? Your drone falling on someone's head. Of course, pretty it's highly unlikely in the agricultural space, but yeah, that's something. So you as a farmer need to understand the laws and regulations guiding drone pilots so that it will enable your decision making when it comes to using them in the farm, right? So let's take a look at some of these regulatory frameworks. So now regulatory frameworks vary from country to country, right? And they have different rules guiding their operations. This includes like your flight altitude, your safety standards, and here are some of them, right? So number one is, for example, you should not fly above 400 feet. So the altitude, the cap given to you as a UAV operator when it comes to operating your drones during standard operations is not to fly above 400 feet. Now, the major reason is because anything aside from that, by the time you start getting to 500 feet, you already entered the manned airspace, which is you now have helicopter operations. And then of course, if you go higher than that, you can most likely going to enter into the manned airspace, right? So 0 to 400 is a good safety margin because it gives you like a 100-meter gap with a 100 feet gap, right? For helicopters altitude. So helicopters generally operate between 500 feet upwards. So when you restrict your operations to 400 feet, there's that gap of okay, now no incidents or no accidents is likely to happen. Now the next one is not flying within 150 meters of a very populated area, right? Of a populated area. Major reason is should your aircraft fail, right? Should your drone fail, the amount of people that will be impacted is minimized or is reduced. Now, if you're flying close to people, if your operation requires you now flying close to people or close to objects, then you have to now restrict, okay, if I'm flying this particular close to these people, the weight of the aircraft I'm going to fly has to reduce compared to if I was flying in an open space. The next one is not flying within or close to an airport, right? Interestingly, there's some drones now that won't even take off once you're close to an airport airspace, but there's some drones that still do. So it is your purview as a drone pilot to ensure that you're not operating close to an airport. Or if at all you have to, you've gotten the necessary waiver, necessary authorization, the ATC is well informed, which is the air traffic controller of the airport you're working in, they're well informed, and that you're in communications with them. And the next one, of course, is to ensure that you're operating within your visual line of sight, right? We say within your visual line of sight so that you're able to constantly know the condition of your aircraft. You have to be situationally aware of what your aircraft is doing per time so that it won't get to a point where your drone is doing something else and then you're like, is this drone going left or is this drone going right? So you being able to see your drone allows you, to have situational awareness, which is important for ensuring safety of both your aircraft and of people and of properties. And the next one, of course, is ensuring that when you're operating within the weather limits, the standards of your aircraft. So, for example, if you are using a drone for survey, let's assume it's a fixed wing drone, and that drone is not waterproof, right? It is not good in quotes for you not to operate it during the rain because when you operate it when rain is falling, you're most likely going to damage it. So knowing the weather limit of your aircraft, for example, what is the maximum wind it can withstand, what's the maximum amount of water it can take in, those kind of things will allow you to operate your drones properly, right? Now, regulatory frameworks, like I said, varies from country to country, right? So, for example, in the US, we have what we call the Federal Aviation Administration. In South Africa, we have the South African Civil Aviation Authority. In the UK, we have the UK Civil Aviation Authority. And then all European countries fall under a body which we call the European Aviation Safety Agency. And for Nigeria, where I'm from, it is the Nigerian Civil Aviation Authority, right? So this governing bodies, right, have regulations that guide pilots. Now, of course, there are some differences from one regulator to another, but generally, like when you look at it, the systems are pretty similar. Right. So the next thing that comes to mind is that when it comes to drone operations in these countries, for many of them, especially if you're operating for commercial purposes, it is important for you as a pilot to get your drone pilot license, which is your remote pilot license. It's what permits you to use drone for commercial purposes. So, for example, as farmers, in as much as your operation involves you making money in the long run, you're expected to have a drone pilot license for your operations, along with, of course, your training of how to operate the aircraft. Hope that's clear. All right. Another concern when it comes to the use of UAVs is privacy issues. privacy issues. Now, privacy concerns arising from drone surveillance have resulted in development of guidance and best practices for drone operations to safeguard privacy rights of individuals. Of course, it's your drones majorly have cameras, depending on the one you're getting. Of course, you are getting a sprayer drone, it might not have one. But let's assume you're using your drone for crop monitoring, for crop scouting. Some of these drones have cameras. And there's usually a concern that if you are putting your drone in a populated area, for example, in a residential area, the neighbors, the people around might have these thoughts in their head where they will believe that you're spying on them, even if that is not the case, right? So to avoid those back and forth, to avoid those misunderstandings, it's important for you to understand that okay, this concerns is available and look for ways through which you can mitigate it, right? Then of course, as farmers, I think it's highly unlikely that you'll be operating close to people because you're operating a farm, which is after you're operating over people, it's most likely those who are under your control, who are under your command, who are also working in that farm, right? So generally, as a drone operator, irrespective of your use case, you are required to obtain consent, right, and ensure data security and confidentiality. So should there be a need, for example, for you to capture a person during your operation, make sure that that person is informed and the person has the content has given you consent, I mean, to go ahead with your operations. And of course, there's what we call data protection. So you as a person are not allowed to just leak information that you get, the data you get to any third party whatsoever, for whatever reason, right? Except, of course, you've gotten the necessary permit and authorization. This will allow for the general public, right, to have a good perception of the UAV space. And it is when they do that the UAV space can thrive. Now, let's talk about the technical considerations when it comes to selecting your drone for agricultural purposes, right? So we already understand what the machine is. It's actually an aircraft, right, which is unmanned and then can be used to gather data for data collection and also for carrying out other tasks like spraying. So what are the considerations, things you need to put in mind? So let's start with the fact that the aircraft is just a subdivision of an entire framework or an ecosystem. So drones, which are also known as unmanned area vehicles, are part of an unmanned aircraft system framework. And the system consists of the drone itself, right? The navigation system, which is like your GPS, and then you also have many others. Now the drone can further be divided into different parts, which includes the airframe, the flight controller, your onboard computer, your communication modules, and your power system. So for the UAS framework now, you have the drone itself, right? Then you have what we call your data link and communication system, which is how you communicate, how you're able to communicate with the aircraft. Majorly either using your controller, which is your handheld controller, or using a ground control station, which could include like your laptop, TV screens, whatever it is. And then of course you have your payload, which is what's attached by aircraft for you to be able to do work. So for example, if you're using your drones for crop spraying, right? Of course, you're going to have a sprayer. If you're using your drones for seedling or planting, the payload is going to be a planter. If you're using your drones to capture data, then your payload is going to be a camera, right? So these are the things that you need to put into consideration when it comes to selecting your drones. Now, the most important one for us now is the payload, because the payload is what you use to do work, right? So let's come and talk about payloads. Now, payloads are the additional equipment, like I've said, that you attach to your drones to perform specific tasks. Now, this includes dropping of objects, spraying chemicals, or utilizing various sensors for data collections. Now, these sensors have a wide range of applications, including using them for obstacle avoidance, right? So we're going to talk a little bit about some of these sensors as we go. Now, in the agricultural space, we have majorly have four kinds of sensors. Number one is your RGB sensor. Number two is your multispectral sensor. Number three, hyperspectral sensor. And then number four, we have the LiDAR sensor. Multispectral, RGB, hyperspectral, LiDAR. And the one other one you can also add is the thermal sensor, which makes it five, thermal sensor. Let's talk about them, sensors. Now, your RGB sensors are simply sensors that view images similar to your eye. So, for example, the camera sensor you have on your phone is an RGB sensor, because the picture you are taking without your phone is exactly what your eyes can see, right? Same color spectrum, same scope, same image, same everything, right? So it is used for visually inspecting crops and also for identifying issues like pest diseases. So we make use of RGB sensors in the agricultural space, right? For detecting crop health, right? And also identifying diseases, that maybe pest infestations, because those things you can highly majorly see them with your eyes. And the next one we have is what we call the multispectral sensors. Now, these multispectral sensors, they capture images across various bands of light, including near infrared. Now, when it comes to lights, right? Lights, we have what we call different we have different bands. So we have what we call your visual band, which is the band of what your eyes can see. But in addition to that, we have what we call the radio waves. We have infrared. We have ultraviolet. We have X-ray. Right? These are also bands of light, but they're not things you can see with your physical eyes. So, for example, if you go to the hospital and you do an X-ray scan, right, and they're able to look through your skeleton, what they actually did was they passed light through your body, but that light is not a light that is visible to your eye, right? So, same thing goes for a multispectral sensor in that it captures the visual band, which is what you can see, then also captures what we call the near infrared band, which is something your eyes cannot see. And then when you infuse those data together, you're able to get what we call multispectral images and not RGB images. And this gives you more details because you have captured extra light beyond what your visual eye can see, right? So we use them for detecting stress, for optimizing irrigation for your farmland. So when you want to do your watering plan or your irrigation plan, multispectral images allows you to create a very structured plan for that. Use them for fertilization, like calculating vegetation indexes, right? Like NDVI. So you have a couple of vegetation indexes that you farmers use for analyzing your crops. One thing allows you to be able to do that is the multispectral sensor. Now, we also have what we call the hyperspectral sensor, which is more like a build up from what your multispectral sensor allows you to do. So it captures more images across more bands, right? And you use them for detection of diseases, for detecting nutrient deficiencies of your plants, and for understanding environmental stressors. And the next one we have is what we call the thermal imaging sensors. So your thermal sensors are pretty much like the name implies, thermal, are used for heat detection. So they detect heat emitted by your crops or by your plants, right? And are based on the heat signals being sent through the crop temperature. You can detect the water stress, you can manage irrigation, right? And you can also use it to detect anomalies in livestock, which is your animals like your cows, your goats, your sheep, whatever it is. But majorly, they are used for identifying stresses and for managing irrigations. So with thermal imaging sensors, you can pretty tell or not whether your plant is properly watered, and then based on that, make decisions on how to improve your crop health. The next one we have is what we call the LiDAR sensors, right? Now, LiDAR stands for light detection and ranging. So basically, laser pulses are sent to the crops, and then the timing it takes for those laser pulses to return back to the sensor is being calculated, and then that data is being used to generate 3D maps and 3D terrains, right? So if you want to create a 3D replica of what your farmland looks like for analysis, you make use of a LiDAR sensor, right? They are used for precision mapping of fields, for contour mapping, for terrain modeling. And what LiDARs do is they help you to maximize your land use management, right? So you can practically detect, okay, this is the part of the land I need to use properly. For irrigation, okay, this place is slopey, so my irrigation plan should come up here so that water flows from this top and then goes to this bottom. Okay, I want my fields to be here because this place is a valley, is low. Those kind of decisions, right? Can be made using LiDAR. Now, each of these sensors, of course, provides data that help farmers make informed decisions. So the major reasons why we're including these UAVs is not just for flying sake or because it looks cool or because it's fine. As farmers, what we are majorly concerned with is productivity, right, and efficiency. so that you can meet the demands, the market demands. Now, these sensors allow you to gather that data, all kinds, and then the information you get by processing that data is what you then use, right, to make those informed decisions and therefore increase and enhance your productivity. So there's an end in mind. It is because of that end that I'm making use of all these sensors, right? And the reason why UAVs and these sensors are predominant now is because they have improved performance, they are reliable, and they have more functionality compared to a farmer just walking through the farm and detecting things by eye. Let's talk about a workflow, right? The workflow when it comes to using drones. Now, to effectively utilize drones in the agriculture, there's a systematic approach that you need to take. And this includes mission planning, right? You plan your mission. What exactly do I want to capture? What do I want to do? What is the end result of this mission I want to carry out? And then you fly, which is your flight execution. So based on the plan, okay, for this operation now, I need to fly a mapping mission over my farm and gather a 2D model of it using a multispectral sensor. That is the plan. Now you fly that plan. After you fly that plan, you go back to your office space, to your farm, to your land, and then you process that data you have captured using your computer system and some agricultural based softwares, right? So you gather that data. For example, now you do your NDVI projections, your indices, and then you check, okay, this is the crop health, this is this. Now, once you have gathered that data, you process it. Then after you processed it, you use the information you get to carry out an analysis to make your decisions, right? So it's mission planning first, which is the first thing you do. You plan your mission. You plan your mission, you fly the mission. How you fly the mission, you process the images you've gathered. That's if you are doing image capturing, of course. You process the image you've gathered, you analyze it, and then what you've gathered is now what you use to make your decisions. Now, of course, the other operations where you're not necessarily processing data. So in this instance, what you are doing is, if you are spraying, is that you plan your mission, which is you want to spray this social amount of land with water, with a fertilizer, whatever it is you want to do. And then based on that plan that you've created, you carry out processes of, okay, filling in your crop sprayer with the necessary chemicals in the necessary ratio, determine your flow rates, etc. And then you now fly that mission, which is you now, spray the farm. It could be in one go, which is if the farm is a small farm and your drone is capable of flying that entire maybe hectare or 1 acres at once. Or there could be multiple flows where you divide that land now into different segments, and then you fly each segment, you fly segments, and then you are done. Right. So there's a systematic process to ensuring that you do all this. Now, when it comes to your mission planning, there are different softwares that you can use, right, for mission planning. Uh, some are generic, for example, like Drone Deploy, like DJI Pilot, like Mission Planner. We also have some that are actually built for the farm. For example, is the Parrot fields or Pix4D fields, right? And then they also use these software can also be used now for carrying out your flights. So if you plan your mission now on Drone Logbook, on Drone Deploy, now you can use that same Drone Deploy app, the interface to fly the mission, right? After you've flown the mission, you can still use the Drone Deploy to process the mission, right? And then you can now use that information to make your decision. In other instances, there are some softwares that only strictly use for mission planning. So, for example, you have Mission Planner. Let's assume your aircraft is using that framework. So, use Mission Planner to plan the mission and to fly the mission. But Mission Planner does not allow you to process the data. Then I say, okay, based on this information, I'm going to use Pix4D, right? And then I use Pix4D field to process the data, analyze the data, and then I make my decision. So you can decide to use you can decide to have one ecosystem that runs everything. You can decide to split it and have different softwares for different aspects of your operations. Now, when it comes to these operations, one thing you need to put in consideration is the pricing, right? So depending on the kind of scope your operation is, we have software that are free, and we have those that are paid, and then we have those that it's one-time subscription, and we have those that have subscription models. So based on your use case and based on how robust your operation is, that will determine the kind of software integration you're going to use. Because softwares, as it were, are the backbone for your operations, right? You can process your data and gather useful information without, having a software to process that information or to gather that information. Hope you are getting it. Is that clear? Clear enough? All right. Now let's just touch a bit on the flight principles of uh, this aircraft, flight principles of this aircraft, right? So now, when it comes to UAVs, like we said, they are aircrafts, right? Now, as aircraft, it's important for you to understand or to have a fundamental understanding of how these operations work because it makes your work more effective and more safe. So if I know exactly at the back end how this aircraft operates, I can easily detect if something is wrong. The way I will operate it is going to be different, right? It's more like a mechanic who has an understanding of how a car operates actually has, a better way of driving in quotes compared to someone who just learned how to drive. All right. So when it comes to aviation, we have four forces of flight, right? The four forces of flight are lift, right? Weight, thrust, and drag, right? So I will try as much as possible not to be go too technical with this. I'll just explain it bit by bit so that you get it. Forces of flight is lift, weight, thrust, right, and drag. Now, the study of this forces of flight is what we call aerodynamics. So aerodynamics is the study of how airflow, right, interacts with an object, how air and an object interacts relative to one another when they are in motion, right? Now, we have lift, weight, thrust, and drag. Lift, for example, is the force that the drone generates to, in quotes, lift, that is to fly. The force allows this aircraft to leave the ground and go up. Is what we call lifting force. Now, this is generated by your aircraft wing for your airplanes, for example, or generated by the blades of your drones. So the way these drones, the way they rotate, the way they work, is that they deflect airflow downwards because of how they are shaped. Newton's thought says for every action, there's an equal but opposite reaction, right? So this deflection of airflow downwards results in a force, which is a downward force. And then the reaction now is now this uplifting force that now pushes the aircraft up. Now, because of course the blade is now attached to your drone, to your motors, to your drone, the drone in turn now lifts up. That's the simplest way to put it, right? And how to explain it is based on differentials. So I have my wings, and then I have air flowing over it. Now, as air begins to flow over the top, because of the curved surfaces of the top of my wings, is what I have here. Because of the curved surfaces, this air accelerates, it speeds up. Now, because it speeds up, the pressure applied reduces compared to the bottom. So the pressure at the bottom is more than the pressure above. So the aircraft is going to go in the direction of the higher pressure, which is up. So that's what lifts your aircraft. Now, the force that opposes lift is what we call weight, right? We've learned about gravity, where we say what goes up must surely come down. So there's a force while the aircraft, while your UAV, while your drone is flying up, that wants to constantly bring this aircraft back to land. That's weight. Now, if the lifting force is more than the weight your aircraft ascends, if the weight is more than the lift generated, your aircraft will descend. That's pretty much it. And then the next thing we have is thrust and drag. Now, thrust is the force that pushes your aircraft, your drone, forward through the air, right? So moving your drone from point A to point B. The force that allows you to do that, to move from point A to point B, is thrust. Now, of course, as we are moving, it's the force that opposes motion, right? The major one we are used to is friction, right? We say friction is the force which opposes motion. So there's a force due to the surface, due to the area of your aircraft, of your UAV, that is trying to pull that aircraft back, right? So if the thrust force is less than the drag, your aircraft either stays put or moves backward. But if the thrust is more than your drag, than this caused by friction or many other forces, you're able to pull through and able to move forward through the air. Now that brings us to the next one, which is the axis of flight. Now, when it comes to flight operations, your UAVs, your drones, especially your multirotors, for instance, which is our reference, is that you can move your drones have what called 3 degrees of freedom. Now, these 3 degrees of freedom, these 6 degrees of freedom happens in three axes. These axes are the lateral axis, the longitudinal axis, and the vertical axis. Now, for your lateral axis, is just imagine your this to be your aircraft, right? And then you have a line that cuts from the left to the right. Now, this is the front of your drone, this is the back of your drone. Are you with me? So this aircraft can move this way. So this is pitching. There's a line here, an imaginary line that cuts like this. The only way I can move about this line is either I go like this or I go like this about this line. right? So this movement now is all called pitching. So for a motor torque now is when it pitches forward, is when it moves forward, it thrusts forward. When it pitches backward, is when it moves backward. And then we have the longitudinal axis, which is a line that goes from the nose to the tail. Note that these lines are imaginary lines. We're just using them to reference our image, right? Our movement. So have a line cutting across this way. There's means this aircraft can move either this way or this way. So we call this movement, we call it roll, right? The aircraft is rolling right or is rolling left. And the next one is we have a line that cuts across vertically from the top to the bottom. All this means as a CG, right? So it cuts vertically. So about this vertical plane, my movement is I can either rotate this way, rotate clockwise, or rotate anti-clockwise. Now this movement is called yaw. And the way I explain to people is this. Let's just take your edge, right? And you say, when I say you're pitching, is you're saying yes. No, that's pitching. Your head is going forward and backward, it's pitching, right? And then you have what we call rolling, which is when you're turning your head to the left and to the right, is your rolling. And then you have what we call yawing, which is when you are changing where you are facing, right? I'm yawing left, I'm yawing right. That's pretty much it. Those are the movements that you use when you control your drone. And of course, we have another flight, which is the up and down, but those are not axis. So we'll get to that. We'll get to that. All right. So let's talk about drone operations. Now, for this segment, what we'll be focusing on is the multi-rotors because they're the most common kind of drones that we have, the most common categories. And like already established before, we have the multi-rotors, we have the fixed wing UAVs, we have the rotorcrafts, and then we have the hybrids. So the most common one among them is the multi-rotors. And that is practically what almost everyone begins with. So we're going to focus on the use of multi-rotors. Now, the control of multi-rotor drones. Now, all drones, irrespective of what they are, generally have four controls in their movements. Right? These are throttle, yaw, pitch, and roll. Throttle, yaw, pitch, and roll. So in this section, we'll be looking at how multi-rotors drones are controlled. Like I said, the major reason we are focusing on multi-rotors is because they are the simplest one. And they're most likely the ones you're going to enter into the market with, right? Before you now advance into the other ones. Now, I come again. Throttle, yaw, pitch, and roll. All right, so let me explain it a little. So remember we spoke about the axis of flight. So we have the vertical axis, longitudinal axis, and we have the lateral axis, right? I said the movement about the longitudinal axis is your rolling movement, which is your aircraft rolling to the left, rolling to the right, or rolling to the left. You have your pitching moment, which is pitching forward for aircraft to go forward, pitching backward for aircraft to go backward, and then you have your yaw, which is turning your aircraft left and right. Now, the way it works for multirotors is that multirotors are operated using what we call thrust differential, that is speed differential. So by varying the speed of our motors, we're able to control the aircraft how we move. Now, throttle control regulates the speed of all the motors simultaneously. So let's take this aircraft. Yeah, right. I have four motors. I have one, I have two, I have three, and then I have four. Right. Now, these four motors, I can either increase the speed of them individually or decrease their speed individually, or I can increase and decrease their speed simultaneously. Now, what allows me to increase and decrease their speed simultaneously is the throttle control. So when I throttle up, what I'm doing is I'm increasing the speed of the four of them equally. Now, when I do that, this aircraft is going to climb because everything is generating equal forces. So the aircraft climbs, so it goes up. Now, when I reduce it, I throttle down, I reduce my acceleration, so my aircraft descends. My lift decreases, so my aircraft descends. That's throttle control. Now, the next control is yaw control. Yaw, which is actually turning the aircraft left or turning it right. Now, this is an explanation. Now, with this picture, Daos, look at this. I have high thrust, which is red, and I have lower thrust, which is the green. That is our code. Now, one thing you need to note for this aircraft is that these four blades are not rotating in the same direction. These four blades here are not rotating in the same direction. So for my blades, what we do is we have two blades that rotate counterclockwise, which you can see in this image here. If you look at this arrow now, this blade rotates counterclockwise. This blade rotates counterclockwise. And then I have two blades that rotate
Hello,
clockwise. Now, why is that?
please.
The reason is because, like we said, for every action, there's an equal but opposite reaction. So if you take your helicopters, for example, right, which actually have one rotor rotating above, right? If that rotor is spinning, the body of the helicopter actually wants to rotate in the other direction. So I don't know if you've watched a movie before where they shoot the tail of an helicopter and then the tail rotor gets damaged. What you notice is that the helicopter spirals down, right? It's because the tail rotor helps to counter that force, that reacting force. So if my blade is rotating clockwise, it wants my it wants the helicopter. The helicopter in turn will rotate anti-clockwise. So normally my helicopter will be spinning, and that is not stable. So the tail rotor is given to counteract it, to counteract that force. Now, if all my blades here, if all these blades here, one, two, three, four, are rotating in the same direction, let's say clockwise, what will happen is that this drone now start rotating anti-clockwise, so it will not
Hello,
be
Mr.
stable.
David. I don't know if you can hear me. Please, the image on the screen is not speaking into what we are saying. I know you're talking about flight theory or principle of flight. The picture we have here, I don't know if you can change the slide from your hand or I'm not seeing the
Okay,
image, so
what's
the
currently showing
image
on
is
my
not
screen?
representing what you're speaking about. What I can see here is a agricultural drone, DJ agricultural drone made here, integrations of drones in agriculture. So I think there's concept if you can. Okay.
Whoa. All right, stand by. How about now, sir? All right, can you see my screen now? Hello, Mr. Joseph. All right, so this is what I was explaining, right? I was just informed that my screen was not showing correctly. All right, so this is what I'm saying. So I have my multi-rotor drones, and I'm saying these four motors do not rotate in the same direction, right? So I have two rotating counterclockwise and I have two rotating clockwise. Major reason is for balance because these clockwise blades, as they rotate, they cause this aircraft to want to rotate in the opposite direction. Now, these two aircrafts, as they rotate counterclockwise, they want my aircraft to rotate clockwise, right? So to create that balance now, I have two motors rotating anti-clockwise and two motors rotating clockwise. Now, when I throttle up, I'm increasing the speed of the two of them. So the force balance between the two of them is equal. So my aircraft ascends or descends. Now, when it comes to yawing, what I do is I either increase the blade of the clockwise blades compared to anti-clockwise, or I increase the blades of the anti-clockwise blades compared to the clockwise. Okay. Now, when I do that, what happens is that if I increase the blade of these anti-clockwise blades, the reaction is a clockwise reaction. So my aircraft will yaw clockwise. If I increase the blades of the clockwise blades, my aircraft will turn anti-clockwise. Remember, for every action is an equal but opposite reaction. Now, for my pitch and for my roll, what I'm doing is I'm doing thrust differential for different sides. So for me to pitch forward, what's happening is I'm increasing the speed of the forward motors or decreasing the speed of the forward motors for me to pitch. If I decrease the speed of these two motors in front and increase the speed of these two motors in the back is going to raise up because I have more lifting force. Now, when the back raises up, my aircraft begins to move forward. Now, the opposite happens for me to pitch backwards, right? I increase the speed of the forward motors and then I decrease the speed of the backward motors. Now, for me to roll, I just reverse it. So I increase the speed of the right motors or increase the speed of the left motors for me to move either left or right. I hope that's clear. All right, I'm going on to the next section. So here is my controller. So my RC now is what allows me to be able to control my movement, the movement of my aircraft. So I have two joysticks. Your RCs majorly have two joysticks, right? So you have the first joystick and then you have the second joystick. Now, the joystick on your left, so they're primarily different modes. I have mode 1, mode 2, mode 3, and mode 4, which tells me about the positioning of my controls. But let's stick to one. The major one, which is the most common one, is my mode 2 controller, right? So this transmitter now allows me to transmit signals to send what I want to do to my drone. My drone receives that command and then carries out the operation. So each of these movements, my pitch movement, my roll movement, my yaw movement, and then my throttle movement is assigned to somewhere on my joystick. So let's look at this mode 2, for example. So look at this. So I have one movement, which is channel 1, which is my roll. I have my channel 2, which is my pitch, right? I have channel 3, which is my throttle, and I have channel 4, which is here, which is my yaw, right? So on this stick now, for example, when I move this my left stick upward and downwards, my drone either climbs or descends. Now when I move this same stick left or right, my drone yaw, it turns yours left or yours right, changes the heading, changes the direction. Meanwhile, for my right stick, when I move it forward and backward, my drone either moves forward or moves backward. And then when I move it left and right, my drone either moves to the right or to the left. That's practically it. Now, those are the main controls: my throttle, my pitch, my roll, and my yaw. Now, aside from that, of course, depending on the kind of operations, there are extra controls I have. So I could have controls for my camera. I could have controls for my sprayer. I could have controls for turning my camera down or up, for turning on and off my sprayer, for determining the flow rate of my aircraft. There are more settings I have. But for movement of my aircraft, those are the controls. Now, we also have what we call flight modes, right? Which is the incorporation of automated missions. So instead of me having to fly the drone myself, I can configure the drone to fly autonomously. So if I want to spray my farm, for example, I don't have to manually fly my drone to spray that farm. Right? What I can do is I can, in my mission planning, I can plan that mission, upload that mission to the drone system using my controller or my GCS, send that command to the drone, and the drone will fly this route autonomously by itself. Right? That's one way to look at it. All right. So when it comes to flight modes, like I said, so we have what we call, these are other flight modes. We have normal mode, which is your regular modes. Now you have time lapse, for example, where you want the drone to take images fast. You have active track. You have waypoint, which is like your mission. If you want to spray farmlands now, you have waypoints, point A to point B, right? And you have many other modes like that. And this is what we call fail safes, right? Now fail safes are practically systems or commands put in place should something fail, right? So for example, should you lose connection with your drone, what is your drone going to do? Should you just stay where it is or should it come back to you? Those are fail safes. Should your battery be low while you're operating? Do you want the drone to just land where it is? Or do you want it to give you a warning and return to home automatically by itself, right? So fail safes are features that are embedded in your aircraft to allow your system to carry out a task and operations to ensure the safety of your aircraft. So if your battery is low, for example, it don't trigger the automatic return to home all by itself, except you cancel it. That is for safety reasons, so that you don't just drop or fall off the sky. Now let's talk about safety considerations. Like we've established before, right? Safety is paramount when it comes to operating drones in agriculture. For example, the drones you'll be using for spraying in the agricultural world, they are pretty heavy. So, for example, imagine a drone that is carrying 10 liters of fertilizers. Now, 10 liters is about, let's say, 10 kg in quotes, right? If that drone were to fall on someone's head, that's a lot. That will cause a lot of damages. So, you as a farmer expected, number one, of course, not to fly above people. So it's highly unlikely that there are people on your farm while you are spraying it, right? So that's number one. So you ensure that okay, nobody on that farm, there's nobody on the farm while you are spraying, because if the drone fail, it can hit someone. How do you do that? Number one, so aside from that, also another thing you can have incorporated is maintaining visual line of sight, ensuring that you can see the aircraft at every point, even though it is flying autonomously, right? So that you can easily pause the operation, stop the operation, carry out avoidance operations, things you need to do to correct what is going wrong, and then you can now resume your operation safely. But if you don't have the visual line of sight, you cannot see the drone while it is operating. There's a high chance you will not be able to do that if things happen to go wrong, right? So maintain visual line of sight. Now, like we said, also avoid operating in restricted airspace. Of course, for your farm, it's highly unlikely that to be operating in restricted airspace. Except, of course, maybe you're contracted to come and operate a drone for a farm that is close to the airport or close to these restricted airspaces. Now, should that be the case, like we said, get necessary waivers, get necessary authorizations from the aviation body before you proceed. Practically do anything that needs to be done to ensure that safety is maintained. One other thing you can do to ensure that is by maintaining your drone, carrying out aircraft maintenance, right? So your drones are machines and they need servicing. So you have to service them, take them to the drone repairer for repairs, carry out firmware updates. If your propeller gets cracked, change it, those kind of things, just to ensure that your aircraft is always airworthy and in good condition. All right, now let's talk about the integration of drones in agriculture. Right. So from our earlier discussions, we've made it evident that drones have numerous applications in precision agriculture. Now, these applications include crop scouting, disease detection, weed management, yield estimation. Right. So to help you understand better, let's explore some of the real world cases. So we want to look at how these drones have been used in many instances, and let's look at what was the benefit of using drones to carry out these operations. So we're going to start with the operation in Brazil. Brazil. Right. Right. So the coffee plantation in Brazil, right? It is in Minas Gerais. Now, in 2018, they implemented a project where they made use of drones to optimize their cultivation practices. Now, so they used these drones, which were equipped with thermal imaging sensors for coffee plantation management. And the project has been ongoing since then. So up to now, the drone is being deployed in this coffee farm, right, to ensure optimizations. Now, the drones allowed real-time monitoring of canopy temperature, and based on the information that they gathered, they're able to carry out drought stress analysis, right, and that helps them to create a better irrigation system, to optimize their irrigation system. And when they did that, they prevented a lot of losses, a lot of crop losses related to water, not having enough water or having enough irrigation. So with the aid of the thermal imaging sensors, they're able to get, okay, water is not getting to all these farmlands very well. Okay, this flow of water is not good. How do we correct it? So based on the data that they got, they now plan their irrigation routes properly, and that allowed them to avoid losses of crops that would have been caused if the farmland was not properly irrigated. And they've been using their drone consistently since then. Aside from that, they also use it to detect pest infestations in their coffee trees, enabling them to carry out pest control. So with the aid of these thermal cameras, also they're able to detect, okay, these crops are being impacted by pests, right? And then those areas that were impacted by pests were being focused on, and pesticides were applied. Instead of having pesticide applied on the entire farm, right? Now it is precise pesticide application, which in turn saves them costs, right? Because now the amount of pesticides they need to buy, or they need to spray reduces, and also optimizes, saves them money, increases their yield, increases their reputation in the market. The next one is the rice yield farm in Asia. So we had rice farmers in Thailand, right, who formed a cooperative, and then they implemented the use of drones equipped with LiDAR, which is light detection and ranging sensor, in their drone cultivation practices. So this was actually a group of small farmers, right? And then it just made sense for them to, instead of having one person each individuals having a drone each. They came together as a group, as a cooperative, and then implemented one drone to service all those rice farms. Right? They launched this project in the year 2019, and they've been periodically using drones to monitor their rice seasons. Right? So they created detailed elevation maps using their lidar, and then what they noticed was that the integration of these drones increased their yield by 25%, increased their yield by 25%, and also reduced the use of water, in the sense that because their irrigation was optimized, right, they didn't need to waste water to overflood some areas, and then some areas did not have water. It was precise irrigation system, irrigation strategy, and that improved their yield. It improved their yield a lot per hectares. Another thing it helped them do is, like we said before, for this coffee farm, was help in fertilizations and pesticides, application, because they had data and they're working with data. It reduced their chemical usage by 15%. Right? Use your chemical usage by 15% means you have more healthy crops grown, and also means you have money saved. The next one is the maize farm in Kenya. Right? So we have maize farmers in Rift Valley in Kenya who implemented the use of drones with multispectral sensor for monitoring their crops. This project was also implemented in the year 2019, and the objective was to improve their maize production practices, to increase yield, and to conserve resources. So as I'm going through all this, you see that the theme is consistent. Yield is being increased, resources is being preserved. So they're conserving water, they're conserving the use of chemicals, they're conserving the use of pesticides, the use of fertilizers, all because they have useful data that they can use to do precise application of all these things. Right? So what these guys noticed that they noticed a 20% reduction in fertilizer usage. You know, of course, the reason for applying fertilizers is to increase our crop yield. But if you don't have enough data to make precise decisions of where to apply the fertilizers, there's a high chance some of the fertilizers you're just imputing actually being wasted because your crops in quotes do not need them because they have enough or sufficient nutrients, right? So you're probably overfeeding some of the plants and then you're underfeeding some. But because now you have this data that you're capturing, you're able to decide and say, okay, this particular plant, this place is well fed. Now this place is being starved. Only this place needs to be fertilized, right? So it reduces the fertilization by 20% while increasing their yield. While increasing their yield. Another one that we have is targeted weed management in the US. So in the US, there's this soybean association or group of farmers also who plant soybeans, and they made use of drones equipped with RGB sensors, which is your normal visual sensors, to detect and map where the weeds are located. And based on that data they captured, they're able to take out those weeds, either using chemicals, right, using herbicides, pesticides, or also like just having the farmers go there, to uproot those weeds, right? So they identified the weed infestations, and then they did targeted herbicides applications. And of course, your drones have GPS, so based on the data captured, they know exactly the location where the herbicides needs to be planted. I mean, needs to be applied, etc. etc. Now let's talk about the challenges and future directions, right? So while it is true that the potential for drones in agriculture is vast, there are some challenges that needs to be overcome, including costs, data management, and regulatory constraints, which we've actually spoken about during the course of this training. Now, small scale farmers who are interested in using drones technology face challenges due to high initial costs and limited financial options. However, as we go, the cost of drone technology has decreased significantly over the past decade. And for example, and cooperatives are also being put together, put in place to ensure that farmers can come together as one, to bring down that cost. So, for example, instead of having a one farmer having to buy a big drone, right? You can have a group of people come together and manage one fleet. Another thing they now do is now they have like drone service companies where the farmers don't outrightly have to purchase these drones. but they just get the services of companies who can offer those services and then get to use those services at a lower cost. Now, another thing is data management and analysis, right? When it comes to data management, as the use of drones expand and increases, the number of data you have to process, the number of data you have to manage, it increases. And in a way, that adds a lot of workload, a lot of work, in addition to what the farmers are already doing, right? In other cases, many of these softwares for you to do this analysis require you need sophisticated softwares. You need to be able to understand data analysis, data reading, decision making based on those data that you have gone. Now, those things in many cases require specialized fields, right? Where someone needs to be able to understand how to read thermal images. Now, that might not be something you as a farmer or farmers want to do, right? But then as technology improves, many of these, as AI begins to improve, artificial intelligence improves, these systems will allow autonomous detection of problems without you having to analyze it manually by yourself. And then, of course, your drones can detect automatically where herbicides needs to be sprayed without you having to be in the loop. So as technology improves, um, the problems we are facing that we're interfacing with will begin to reduce. And then, like we've seen already, the returns of implementing drones into the use of technology into precision agriculture is vast, and that will allow us to meet the demand of food as our population begin to arise. This brings me to the end of my class. So, like we said, the drones have the potential to transform modern agriculture by optimizing resource utilization, increasing productivity, and minimizing environmental impact. This impact is evident by the increasing adoption rates and the tangible benefits that farmers are experiencing. Drones have immense potential in the agricultural space, and as time goes on, we believe that this advance in technology will help us to overcome the barriers we are facing when it comes to food production and that the world will no longer go hungry. Thanks for listening. Questions and answers can come now. So if you have any questions, just kindly type it in the comment section and then we'll handle that.
Okay, thank you so much for the presentation. And I think our participants really enjoyed your section because I've seen a lot of, good responses and encomiums like, um, so I
Thank you,
think
sir.
it's an explicit section. There are a lot of good. So we are expecting your questions, please. You can do well to drop them so you can help us attend to that. Okay, I think I've seen one already. What are the main ethical and legal challenges associated with the widespread use to drones in civilian areas? I don't know if you get that question.
All right. So ethical challenges, of course, the question is straightforward and it's a good question. Like we said, we've raised privacy concerns, right? So generally, the outlook of people when you have a camera pointed at them is that you are spying on them. That's just it. That's number one. That's what we believe, right? Until we find out that it is not the case in most cases, right? So there's that concern that people have when you have a drone flying overhead that they're being spied on. Now, people don't necessarily want to have their personal lives, right, being displayed or being accessed by just anyone, right? So there's that. So it's about you as a farmer understanding these concerns and doing everything possible to ensure that you are in the right. So if, for example, you need to fly over people that are not necessarily in your operations, that don't necessarily know you need to have their consent and their permission to fly over them, especially if you'll be capturing their image or their data. So if, for example, I was doing a documentary, right, of let's say Lagos mainland, of life in Itire, for instance, and then I'm using my drones to capture these videos. Now, of course, the people are going to show up in my videos because I'm capturing informations about a populated area. Now, these people do not necessarily maybe want to see themselves on TV, right? Because maybe they just don't like it. those people now who are going to be featured in quotes need to give me the go ahead to say, oh yes, you can use my, can I use, I just took a video of you on this so and so. Or even before you take that video, you've already spoken to them that, oh, I'm taking a video of this area. So you are here. Are you saying, are you okay with me filming with you inside it? Right. So that allows you to cut through that barrier. So that's one. Now, number two is the fact that, like we said now, like Facebook, for example, had a lot of problems where we said they were selling the private data of people to others for the purpose of making money. And that's why when you open new softwares, right, they tell you to read their policies, their privacy policy, and you read, this is to note that your information, your pictures, your phone numbers, your details, your whatever will not be sold to a third party except explicitly needed for regulatory purposes, blah blah blah. Right? It is, and they ask for your consent. In that, in this documentation now, you're writing your phone number, your email address, your pictures, your everything. This can be sold. They can use that to target you, in quotes, right? So ethically, you don't want to be in the position where you are seen as someone who sells people's data for profit reasons or for other reasons that are not legal, right? That are not ethical. So knowing that and then putting structures in place to ensure that those things are done are a way to go. I hope that answers the question. Any other questions?
Are throttle and trust the same thing?
Are throttle and trust the same thing? Not
Yes.
necessarily. Okay, so for your multirotors, right? The way it works is that your throttle control helps with your lift, right? Which is your aircraft going up and going down. Now, for your multirotors, this thrust and lift are somewhat mixed in the sense that the blades that are providing your thrust are also the same blades that are providing your lift, unlike your airplane. So for your airplanes, for example, what provides your thrust is your jet engine, right, which is located under the wings in most cases. And then that's providing your forward motion. And then what generates your lift is the wing of the aircraft itself. Now, for a multirotor, it's a little bit meshed such that it is the same blades that you're using to take off and land, which is for your throttle, your lift. Also, the same blades that you are using to pitch forward, to pitch backward, to roll left, to roll right, right? So it's more like this you're rolling now, it's more like you are thrusting to the left, thrusting to the right, thrusting forward, thrusting backward, right? Using the same blades. So your throttle control, what it does, it just allows you to control those that thrust in quotes, which is now also lift in the upward and downward direction, which means for your aircraft to go up and come down. That's what your throttle does. Meanwhile, your pitch, your roll control allows you to control your thrust, but it's now directional. So thrust forward, thrust left, thrust back, thrust right.
Okay. Another question here is, uh, what are the difference between LiDAR and camera-based sensor used in drone mapping? I think okay, it's talking about LiDAR and RGB
All right.
from.
So like we've already established, your RGB sensors practically captures your normal images, like what your phone can capture, right? Just pictures. What your eyes can see is what your drones capture. The only difference is that with a drone now, you have a higher vantage point. So with your eyes, there's a limit to what you can see. But with the drone now, it's more like you have a camera, the phone camera now, and then you mounted it on a mast or you mounted it on a tall building. Then you're able to see more. That is the advantage of the RGB. It is still the same images you are capturing, which is like similar to what your eyes can see, right? But then you have a higher vantage point. Now, for LiDAR, it's a bit different. You're not capturing what your eyes can see. What you're capturing is you're capturing the response of this UAV based on light. So you're capturing light data. This light data now, for example, it penetrates through the grounds. So in an instance, your RGB sensors, what you can see is limited by what your eyes can see. The leaves are blocking you, right? But with a LiDAR now, the light can penetrate through the leaves, enter into the leaves, even penetrate through the ground. So I'm not just getting the data about the surface, which is the leaves on your farm, I'm getting the information about the ground, even though the leaf is covering it. right? With your RGB sensor now, is what you will see when you look up is just the green grass. You cannot see the ground. You cannot see the soil. You don't know the condition of the soil until you now go down and go and check it by yourself. With LiDAR, I don't have to go down to check it by myself. The light penetrates through every single thing. The image I even get is not my regular photo image. It's a LiDAR image, a LiDAR vegetation map, a vegetation index. And then that gives me more data compared to what my RGB can see. So with more data now, I can make more decisions. Because I have more information.
Okay,
Hope that's
thank
clear.
you. This person is asking how can farmers maintain these drones to ensure it lasts long, and what's the cost of maintenance?
All right. So the question is, it depends, right? So majorly there are two options. The first one is you can decide to have your maintenance team in-house. So you can be a farmer and maybe you own your drone by yourself. Now you can decide that because you own this your drone by yourself, you want to be able to maintain it by yourself. Of course, which means you're going to have trained people who understand the in and out of those drones and then can then maintain it. Or you can decide to outsource it. So even if you have the drone internally by yourself, you can decide, okay, I don't want to be involved in the repair of this drone. So if this drone has any issue, I'm going to give it to someone who knows or who specializes in fixing these drones to maintain it for me. So you can decide to now have an engagement or an agreement that, hello, so and so company. Um, I have so and so drones in my fleet, and I want you to help me to maintain them to ensure that these aircrafts are constantly airworthy. Based on that, of course, when your drone has issues, when your drone has firmware issues, whatever, you're constantly calling the people to help you out. So those are the two options, right? Which is have your technical team in-house who are constantly monitoring the conditions of the aircraft for you and then fixing operations as you go. Or you can have a third-party service who helps you to fix your drone whenever issue arises. Now that's one. How then do you now ensure that your aircrafts are always maintained and fully functional? It comes with many things. Number one is being aware about what the normal condition of your drone is supposed to be. So, for example, if you're operating your drone and then it pops up an error, then means something is wrong, right? So, being at alert, not just overlooking errors when they come up, not just overlooking accidents or incidents, carrying out your pre-flight checklist, right? So, if you're a farmer and then you're flying your drone, ensuring that you carry out a checklist pre and post flight. Okay, I checked this drone today. So, let's say every week or every day before I fly. I'll check the condition of my drone. Then I checked today. I saw that the propeller was broken. The propeller was cracked. That is a sign. This is good for me to maintain it, right? I have my batteries. I'm charging my batteries. And then I notice that my batteries begin to swell. I noticed that before, when I fly it, this battery lasts for 20 minutes. Now it's lasting for 10 minutes. Those are pointers, right? It is when those pointers come, when you receive those pointers, it is making sure that you deal with them and not just putting them by the side, not just deferring them and saying you do them later. Fix them now. Any prompt you have, if it is your internal team, inform them. If it is your external team, let them know so that you can take your drone to them for servicing or whatever that is. And then, of course, constantly updating your drone's firmware, right? So as you begin to use your drone or as time passes, manufacturers tend to send updates, firmware updates to optimize the effectiveness of your drone. Just make sure that your aircraft is updated all the way, and then doing your necessary calibrations, etc. I think that covers it.
Okay, thank you very much. This person is asking how feasible drones for small farmers.
All right, so it depends on what you mean by small farmers, but I think I understand the scope in the sense that okay, maybe you're a small farmer and you don't believe at the moment that you're capable of owning a drone. Yeah, that's why I said cooperatives come in, and that's also where using third-party services come in. So if you're a small farmer, there's a high chance that the initial cost of you getting a drone to start using in your farm is not the best decision to make at this moment. So what you can do is either have cooperatives who are integrating these drone operations where it's not just only you now. So more like a gathering of small farmers working together. That will cut down the cost for you. Or another one is the incorporation of third party services. So instead of you owning the drone by yourself, is having someone who offers these services, a company that offers these services, and then being serviced by them. So you tell them, oh, I want to help me to spray my farm, have a maize farm, every so and so. and then you come up to an agreement, a payment plan, and then you are good to go.
Okay, thank you. He's asking what's the most weight an agricultural drone can carry, i.e., per
Uh,
bag of fertilizer.
okay. So I'll say it depends on the drone you are getting, right? It depends on the drone. So for example, I think DJI just released another drone that's capable of carrying 100, is it 100 kg, 100 liters, if I'm correct? Right. So before, as technology improves, the capacity of the drones begins to increase. Before we had just drones that could carry 10 liters, right? Which means with a 10 liter now, I need to have more runs if my farm is big. Then later it grew to 20 liters. Later we had drones that could carry 30 liters. Later we had drones that could carry 40 liters, right? And then now I think we have drones that can carry more than that. So it depends on, as technology advances, the capacity increases, and then also depending on the size of your farm. So for your farm, for example, if it's a small farm, you might not be need to have a drone that carries up to 100 liter because you don't necessarily need 100 liter to spray that farm, right? So those are the things you just weigh in. But yes, up to 100 at the moment that I know of.
Okay, thank you. This person is asking, what are the legal requirements for flying drones in Nigeria?
All right. So in Nigeria at the moment is the fact that if you're operating drones commercially, right, that is for the purpose of financial gain, in quotes, you need to be licensed. You need to have a drone pilot license, right? So like more like your driver's license. So this is a license that allows you to fly your drone commercially. The body for managing aviation in Nigeria is the Nigerian Civil Aviation Authority. You can check them out at www.ncaa, that is Nigeria, N, Civil, C, Aviation, A, Authority, A, .org, www.ncaa.org. That's the body, right? So number one is having your drones, having your pilot license. And the next one is if you're operating commercially, you have to have your drone registered with the NCAA. There's a process to do that. I believe if you reach out to the NCAA, they'll provide you all the information you need.
Okay, thank you. This person is asking, what data is used to plan a flight? Does it rely on any existing map of the area to do this?
All right, so the way your drone function is, like I said, your drone has GPS embedded. So on your application, if you open your drone application, for instance, you are going to see a map. Now that map actually shows, which shows actually where you are. So you can plot. It's more like you're using Google Earth or using Google Maps. So you can use that to plot the details of to plot the routes of your farm. Now it might not be as precise as possible, but there are ways to go about it, right? There are ways your applications allow you to plot the edges or the limitations of your farm. So you can do that either by flying the drone itself to get those points, your point A, your point B, etc. And then based on that data, you're able to do that. Another way to do it is for some drones, what they do is a drone actually first flies over to map the entire area. Now, after it has mapped the area, the map is now being used by the sprayer drone to carry out the spraying. So yes, so it's more like you have your Google Earth, right, or your Google Maps. That is sufficient enough because you know where you are, right? So if your farm is in Itedo now, for example, so you open map Itedo. If your drone is even powered on, your drone has a GPS. It will show you where your drone is located, right? And then of course you know how your farm looks like. So you see if maybe there's a wall here, you see the wall, you see the farm in quotes, depending on how updated the satellite is or the map is, right? Because now you're using pre-captured data, satellite images. Your Google Earth now using I know using real-time map, you're using like old maps, right? So if it's updated, then you can be able to see, oh, this is my farmland, and they can plot the limitations, the edges of that farm based on that map. Or you can decide to just fly. There are different options depending on the drone, right? Where you can pick point A, point B, point C, all those points, and then able to fly using that, using their coordinates, GPS coordinates, long and lat.
Okay, thank you. He said,
Yes, sir.
apart from the two challenges mentioned, Are there more challenges faced for the use of drones technology in agriculture?
Uh, Right. Well, I'll say yes. I won't say no. And then when it comes to the challenges, it varies from country to country, it varies from place to place, right? So, for example, let me use Nigeria for example. For a period of time now, you needed to have a drone pilot license, for example, for you to work commercially. And then, even though the NCA required it, there was no formal structure for you to have that. So people needed to travel outside the country, to get those licenses. So that's one of the limitations, depending on the country. So in that during that period, for example, while countries like Rwanda, Kenya had a framework for getting pilot license, Nigeria did not have it during that time. So those challenges now can vary based on where you are, based on your location, based on your limitations. For example, now if you are to bring a drone into the country, right? What does your country say about it? Is it easy to bring that drone in, or is it difficult? Right? Are there companies who can offer these services to you, or are there not? Are there repair centers, or are there not? Are there places you can purchase the drone in country, or don't we have them, right? So depend on your location, depends on the kind of operations you want to do, the limitations, the problems, the challenges varies based on that. But I just give some more examples.
Okay, thank you. Another question we have here is what obstacles hinders the adoption of drones in agriculture and what strategies can be employed to overcome them for modern farming advancements in Nigeria?
So can I come again with the question?
What obstacles hinder the adoption of drones in agriculture and what strategies can be employed to overcome them for modern farming advancements in Nigeria?
All right. Okay. Good question. So I think I'll say one of the major things is awareness, right? That's the very first thing. You can have something and then not know that you have that thing, or you can know that you have something but not know what it is for, right? So the very first thing is awareness, and that's why programs like this, for example, are a good start, right? Where farmers become aware that there's a technology they can incorporate in their farmland to increase their efficiency and their productivity. So that's number one, which is, are you aware that there's this technology, or all you know about is using knapsack sprayers, right? So the knowledge gap is number one. So the more people are aware of the technological solutions that are available by incorporating drones, right, the more we will see it being integrated. So that's number one. Number two in Nigeria, I would say, is the regulatory framework, right? And of course, it's getting better. And then number three will be, the availability of the drones, the availability of companies that offer the services needed by farmers, right? So we have more of them, coming up. For example, we have integrated area precision, right, which services, farmers both small scale and large scale, which also helps them with training, helps them with, you know, getting their drone, purchasing their drones, and if they want to outrightly purchase, helps them with by offering the services to them, right? So that's it. So the more of those companies that we have, the more of those solutions that we have, the more of those people that are aware, the more of the pilot trains, the more of the drones that are available, you know, the lesser and lesser the problems we have. So those are the roadblocks, and those are the solutions to them.
Mr. David, this person is asking, like, how is the operator able to determine the exact quantity of irrigation a particular portion of farm requires after the analysis? Which of the drone deploy app or AI embedded for analysis and output? Okay, like I think he's asking, like, from the data, were you able to
Yes, sir.
know the amount of chemical to be sprayed on a particular farmland, or how is that done? I think that's
All
what.
right. So at the moment, you are the one that's going to do the calculation, right? Like I said, under this system, you have to call it data analysis. So data analysis is a specialty, is something you learn. So for example, if you if you learn how to use, if you decide to go through using drones for agricultural purposes, one of the things you learn is how to use the data you capture to make useful decisions. And that decision includes determining the amount of fertilizers you need, your spray rates per flight, all those kind of things. So those things are embedded in your specific training related to your farmland, related to the aircraft you're operating, related to the services or the use case you have. So when you go through your specialized trainings, you learn all that.
Okay, thank you very much. He is asking, what possible could be okay? He said, "Does a single drone comes with all the sensory capability? Which model would you recommend for starters, for beginners who are?"
Not necessarily. No, 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 no. So these drones are actually specialized. So even though you can have a drone that has both a thermal and RGB sensor, right? You can also have another drone that has just RGB. You can have another drone that has just thermal sensor. Or you can even have a drone where you can swap the payload, which is you can remove this platform allows you to connect the RGB sensor. You can disconnect it, and then you can connect a LiDAR sensor. You can disconnect LiDAR sensor. You can connect a thermal imaging sensor. So you have that. And then, but when it comes to spraying now, it's extremely difficult or it's rare to have a drone that does spraying. And then at that same time, is that drone that you're using for crop analysis, right? So for some payloads, yes, some aircraft have interchangeable payloads. And then that will determine your scope of operation will determine the one to go for. So if your limitations, if what you need is just a drone that has thermal imaging capabilities, then you might as well just go for that. But if you need something where you have where you need to have multiple sensors, right? You can now decide to have one that has interchangeable payloads where for these flights you fly with RGB, and then for the next flight you fly with multispectral. Or you can have one that includes RGB and multispectral. But then if you have done that and then you need to spray your crops, then you need to get a sprayer, which is a different drone entirely.
Okay, thank you very much.
Yeah,
This
yeah.
person is asking, a drone with a fail-safe to return home or land. When the battery is down, aren't they prone to severe damage?
Not necessarily. Right. So the way it works is not that your battery goes to zero and then the aircraft just returns home at 0%. No. So while your drone is flying, the way the technology works is it is calculating the amount of battery it needs to return to home. That is the battery that is sufficient enough for it to return to home. So for example, if you are flying, you don't just your drone just doesn't automatically drop to zero and then now use 0% to come home. No. So it is calculating. So if it requires 30% for it to come home, and 30% your aircraft will trigger a return to home and then to come by itself. And the drones are smart enough that they land pretty softly, except of course where you took off from was bad.
Okay. He's saying, as a recreational drone flyer, what are the prerequisites or factors to put in place before flying the drones?
I think the very same thing is at the core of it, regardless of what you use your drones for, is to have a safety mindset, right? There's a saying that safety in the air begins in the ground. Safety first before anything. We used to say we say every takeoff is optional, every landing is mandatory, right? It is the way you land that differs, whether you land safely or not. So once you have a safety culture in mind, once you know, okay, I need to operate this aircraft legally, I need to operate this aircraft with safety in mind, with the fact that I know that I can hurt people and I don't want to hurt them. Um, my aircraft can get damaged and I don't want to damage it. So once you are safety conscious and you follow through procedures, you do your pre-flight checks, you ensure that your aircraft is airworthy, you maintain your aircraft, you fly responsibly, then you are good to go.
Okay. After this question, we are going to take one more question and we'll close this session. Our time is fast spent. So, how do drones maintain stable flight in adverse weather conditions such as strong wind and heavy rain?
All right, so like we said, each drone actually has its limits, right? Each drone has its own weather limitations. Now, when it comes to managing or handling winds, right? What we have is your drone has a GPS. Now, your GPS allows your aircraft to know its position. Now, with the positioning of your GPS, your aircraft precisely knows where its location is supposed to be. So if there's a wind drift that is within the limits of that drone use case, your drone actually holds that position based on that information, right? So those sensors work hand in hand to ensure the drone knows where it's supposed to be and tries to be there.
Okay. One more question. I'm trying to check. Okay. She's asking, can you attach a lidar sensor to a drone, or are there drones that comes with lidar sensor or other sensor? Okay.
So we have drones that are built with LiDAR sensors embedded, and we have drones with interchangeable payloads that allows you to add LiDAR sensors to them. Yes, so both of them. Yes, yes.
Okay, I think you did justice to the question and answer section too. Thank you so much for your time. It's
Thank,
really an interesting time with you, and
thank you,
it
sir.
truly shows that you are well knowledgeable in this field, and you. It's an excellent presentation because participants and audience, like in the comment section, they are just showing remarkable presentation. Uh, yes, so
Thank you for the opportunity,
yeah,
sir.
well done for that. It's such a great pleasure to have you. Okay, before you go, I just want you to share a word with them. People experiencing or participants currently passing through the Core 3 program. Do you have any word of encouragement to share with them? It's
Yeah, yeah.
headways to give, yes, before we call it a day.
Yeah, I just want you to know that the fact that you are here shows that you're making a good decision, right? You say technology, a man who chooses not to use technology in this age will be left behind, right? So the fact that you are here trying to, upgrade yourself to know more is a good indication that you're on the right track, right? So don't give up, don't give in, press on. The future is bright for everyone. Happy flying.
Okay, all right. Thank you so much, Mr. David.
All right,
So,
thank you, sir.
everyone, we finally come to the end of this presentation. So, you can also do well to re-watch it, maybe later at your time, if you, yes, to get a clearer understanding. So, attendance will be sent to the group. We also have some classes tomorrow, so information will be communicated for time ahead so that you can prepare for that. But know that we have also two classes tomorrow, just like we did today. So, all right, everyone, bye for now. So, share the attendance to the group and for people in the email as well, so you'll be able to attend. Ensure the morning section, if you attend the morning section, ensure you fill the attendance. The afternoon section as well, fill the attendance. So, show that. All right, thank you very much, everyone. Bye for now.